All right, Honors Chem, this is your assignment for Lesson 15. It's a short one, and I hope maybe you can get through this before we leave on break. So let me go ahead and just run through a few of these. So I'm just asking you to identify reactions. So you get watch the instruction video so you learn what each of these types of reactions are. I'll go ahead and do just a few of them with you here. It's possible some could be classified as two different types of reactions, but generally speaking, no, they're going to be one of these four. All right, so let's look at number one. It's a Ki and then a Pb. And one thing I wanted to address was, what do you do with something like that? That NO3 is a nitrate, and you treat it just like an element, like a single element. It's in parentheses. The nitrogen and the oxygen, the three oxygens actually, are not going to come apart. So you'll notice they show up over here in that exact same 4NO3. So you can treat them. What they are is they are an anion, just like a nonmetal, fluorine, chlorine, oxygen. They're an anion. They're a negative charge. The Pb is a metal. It's a positive charge. So this is an ionic bond. Now the bond between the nitrogen and the oxygens is a covalent bond because those are two nonmetals. But anyway, so what we have is an ionic bond here and an ionic bond here. Iodine is a nonmetal, potassium is a metal. So what's happening in this reaction is the potassium and the iodine dissociate. The potassium comes over and joins up with the NO3. So you see that happening right there. And then the lead here, Pb, comes over and joins up with the iodine. So it's lead iodide. And so that's a double replacement reaction. The K comes over to here, and the Pb comes over to there. So it's a double replacement reaction. Two things, two different elements switch places. All right. This is a combustion reaction. Again, it has an O2, and it's going to produce CO2 and H2O. So let me write that down. This is double replacement. This one is combustion. And let's do one more for you here. This is one you're going to see coming up here in the next part of this lesson. You have a single element. Here you have an ionic compound, a metal and a nonmetal ionically bonded. And what happens, the nickel, this is a metal, this is a metal, they switch places. So the magnesium comes out and becomes a lone element, and the nickel joins up with the oxygen to become nickel oxide. So that's a single replacement reaction. And I don't think these are too hard, so I'm going to let you go ahead and classify the rest of them. Again, you have to watch the instruction video to know what these names mean and to understand this. So go ahead and just, like I'm doing right here, no complete sentences, just write the answer right next to the equation, and that's it. Okay, let's go on to the second part, and that has to do with activity series. Again, I'm assuming you've watched the instruction video. Please watch that first. And let's see, I give you not a lot of these, I give you 5 of these, so I'll do a couple of them with you here. So the rule is very simple. If the lone element, for example, in this case nickel, in this case zinc, in this case Na, sodium, if it is up above the metal that's in the ionic compound, so in this case magnesium, if the nickel is up above it on this list, that reaction will go forward. It will take place. If this is below magnesium, if this one, the lone element out here, is below the element that's in the ionic compound, the reaction won't take place. In other words, the nickel and the magnesium oxide will just sit there in the water or the solution and nothing's going to happen. If the Zn is up above the calcium on this activity series up here, then this reaction will take place. If it's not, if the Zn is down below calcium, that reaction won't take place. Again, you'll just end up with this compound and this element just sitting there in water. Okay, so let's go ahead and do this one. Now that should be a subscripted too, so let me write that. So should that didn't get changed. Okay, so here's magnesium and copper. So let's see where magnesium is. Magnesium is right here, and copper is right here. So magnesium is above copper. Again, what that means is the copper, the elements up here on the top are weak. They easily give up electrons, and they don't pull in electrons very well. The ones down here, they're not nonmetals. They're not what we call strong guys, but they're stronger than these are. They're transition metals. They're further to the right on the periodic table, and therefore they're better at pulling in electrons and holding on to their own electrons than these are up here. So one of these will pull electrons away from one of these. In other words, as long as it's lower on the activity series here than one up above, it'll pull electrons away from it. So even barium, for example, would pull an electron away from potassium because barium is below potassium. All right, so the electrons fall down. So if the magnesium is higher up, it's weaker. It's going to pass electrons down to copper. Okay, so in this equation, magnesium, the lone element, is above copper, so this reaction will take place. You can just actually write, I was going to write will take place, you can just actually write yes. Yes meaning it will take place. All right, let's do this one, number 12. Zinc and calcium. So this one was in the instruction video. So zinc is right here. Let me go ahead and erase these right now. Zinc is here, calcium is up here. So zinc is below calcium. So zinc is not going to pass its electrons up the activity series to calcium. Zinc is stronger than calcium. Therefore, zinc is not going to pass its electrons to calcium, so this reaction will not take place. Again, go back and watch the explanation in the instruction video. Okay, so I only gave you 5 of these in all, so you do these 2 and the one on the next page. All right, so identify whether that reaction will take place or not. Okay, in this final set of problems, I'm going to ask you to use a little creativity here. And this will help reinforce the concept that we've been working on today. So based on the activity series, write 3 single replacement reactions that will work and show the charges. All right, so for a reaction to work, the metal that's part of the ionic compound has to be down low. And the one that's the lone element out there by itself at the beginning has to be up high so that the metal inside the ionic compound will pull electrons down from this element up here. So it has to be a strong guy down here that can pull electrons from there, from the top, and therefore and make the reaction take place. So I picked copper. You could have picked anything you want. And I picked oxygen. The reason is there's 2 types of copper. But I'm going to pick, there's a copper 1+ and a copper 2+. I decided we'll go with the copper 2+. Again, you get to choose this. And that matches up perfectly with oxygen because oxygen's a 2-. So 1 copper 2+, oxygen 2- match up. They form an ionic bond. That forms a balanced charge and an ionic bond. So that's why I picked, so copper 2+, oxygen 2- forms copper 2 oxide right there. Okay, so that's going to be the ionic compound I start with. So there you see the copper has the 2+, the oxygen has the 2-, so that's an electrically neutral compound right there. Now, I need to pick an element that's a metal that's up above copper, and that's pretty easy because almost everything is up above copper. It's up here because copper has to be stronger than the element I'm going to pick, so I'm going to pick magnesium. And the other reason I picked magnesium is it has a 2+ charge just like the copper does. In other words, the magnesium likes to give away 2 electrons, just like the copper 2 like to give away 2 electrons. So what I'm going to do then here, and it is up above copper, so what I did was I put it out here. So what's going to happen is the copper gave up 2 electrons to oxygen. Oxygen became a 2-, copper became a 2+, so they stick together, they bond. Now I need, copper's going to be the strong guy now. Not super strong, not as strong as oxygen, but it's going to be a strong guy. It's 2+, it's going to be able to take 2 electrons away from magnesium, because magnesium is a 2+ charge, charge metal. So it's going to give up 2 electrons to the copper. What that does is it gives copper back its 2 electrons. It now is electrically neutral, If it's electrically neutral, it has no charge. It will no longer be attracted to the oxygen with a charge. So it's just going to go off by itself right there like that. The magnesium gave up 2 electrons. It's now going to have a 2+ charge because it gave up 2 of those negative electrons. So it's now going to be attracted to the O here. So the magnesium becomes the 2+. The oxygen was always the 2-, so they form the bond. And the copper is now the lone element. So that's all I'm asking you to do is come up with a reaction that will work. The one where this one is weaker than this one, where this one will give up electrons to this metal right here. Okay, so you can go ahead and use this one for problem 16. Now you got to come up with your own for 17 and 18. Okay, there are many right answers. Okay, this is not a thing where there's one right answer. There's many. You just think of the compounds you're going to use, of the elements you're going to use to form a reaction, a single replacement reaction that will actually work. Okay, that's it. I'm going to leave that to you. I hope you all have a nice vacation if I don't see you again. Otherwise, I'll see some of you in class on Friday. And go ahead, if you can try to get this done before the break, that'll give you that much less to do. Okay, so you take care, and we'll see you next time.